Morning, everyone. Welcome back to the Aquarium of the Pacific's online academy. My name is Dana, and this morning you and I are going to be exploring a deep sea habitat and learning all about bioluminescence, the way animals survive down there, and the adaptations they have to help them do so. We might be learning about how animals communicate, how they avoid predation. There's going to be all sorts of things for us to discover this morning. But before we begin, I do want to thank you all for being here and watching our program. I recognize that this is normally the Spanish program slot, our Wednesdays at 10 a.m. Unfortunately, we're not going to be running this program in Spanish today. I can speak a little bit, but not enough to do it justice. So we will be talking about the same subject that our Spanish program that was scheduled was going to be about, but it will be in English. Now, if you're out there and you're watching, you are still welcome to submit questions in Spanish or English. We'll be able to answer them in English. But we want to thank you for sticking around, and we do hope to be back to our Spanish programming next Wednesday. So, with that being said, throughout this program, as we participate, we always have this text line right here that's available for you friends to say hello. So that number is 562-286-1838, and my friend Sarah is hanging out behind the computer, working her magic, and she will be communicating on the text line, passing your questions, comments, observations into me, and controlling the magic that we see on the screen here. So I might be the one teaching, but Sarah's the one running. So let's go ahead and see where Sarah starts us first. Like I said, we're going to be learning all about the deep sea habitat. So maybe we can get an idea of what a deep sea habitat might look like. Wow. What do you see here? What's on the screen? Does anything stand out to you? I'm going to step off and give you a minute to make some observations. All right, sorry about that delay. I had some issues with my microphone. But again, my question was, what do you notice? What do you see on the screen here? Does this look like a beautiful coral reef or kelp forest habitat that we're usually exploring on this show? Not really. So today we're going to be looking at a habitat that tends to be much darker, much deeper, and much, much colder. Although I'll tell you, I've been on some dives out here off the coast of California, and I swear I'm 3 miles down below the surface of the ocean. It is so cold. But I wouldn't actually be able to survive down there because of all those things I just mentioned. It's deep, it's dark, it's cold, and there's a lot of pressure, okay? So I want you all to stand there, and I want you to tap the top of your shoulders. Right now, you have the weight of the atmosphere on your shoulders. I know, it's a lot. Sarah's back there like, oh my gosh, no wonder I'm so tired. We are carrying around the weight of the atmosphere. And what I mean when I say that is from here all the way to the top, all of those gases that make up our atmosphere and allow us to breathe and survive on this beautiful planet is resting on our shoulders. And your friend's shoulders. And your dog's shoulders. And your cat's shoulders. We're sharing the weight. That's right, Sarah. Thank you. And so what's important to know is right now, our bodies are very, very well adapted. Now remember, an adaptation is something that an animal has, that's right, we're animals, on or in our body that helps them survive. So our adaptations, such as our nice, strong, muscular and skeletal system, help us stand up and live in this heavy atmospheric weighted environment. We also, our lungs are designed and adapted to be able to breathe in at this pressure level. Ready? Take a big breath with me. All right. Now, as we go into the ocean, every 30, there's segments as you go down, and every 30 feet or so, you get one more atmosphere of pressure. So at 30 feet, 33 feet, I'm at 2 atmospheres of pressure. Now, my body's not adapted to that, so it might be a little bit harder to breathe. It might feel a little heavier around me. If I go 60 feet down, it's going to be even more. My lungs are working differently. Even if I bring air with me like a scuba diver, at 60 feet, when I take that breath in, that air is condensed a little bit, okay? Now at 90 feet, it's even deeper, and so on and so forth. And so again, that's just at 90 feet. Imagine going all the way down 3 miles below the surface of the ocean. You're going to be under a lot of pressure. So much so that in the deep, deep, deep depths of our ocean, okay, everyone give me like an okay sign, all right? A little circle like that. Now in this little circle, or about the size of a postage stamp, you can have so much pressure that it's like an entire school bus is just sitting on just that part of your body. Okay? So imagine taking a postage stamp and sticking it here and 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 here, and we could be here all day, covering your body in postage stamps. And every one of those postage stamps weighs the same as a school bus. Ugh! All of a sudden, our 1 atmosphere of pressure that you and I are hanging out in right now feels very, very light and definitely like something we can handle. And that's why we are so well adapted to live where we are. But we are not adapted to be down there or down in this habitat right here. So what about the animals that live there? I'm going to step off screen and have Sarah maybe pull up another deep sea photo. And I want to just give you a minute to think about the animals that might call the deep sea home. They're not going to look like us. They're not even going to breathe like us. They might not even be the same size as us. There's so many factors that are at play here. I want you to maybe brainstorm and think of if you've heard of any deep sea animals. Go ahead and text us in at 562-286-1838. What animal might you find in a habitat like this? Now here's a great video to maybe give us an idea as well. What do you see? What's going on here? Oh, what's that? Something to ask yourself. What colors do you see on this screen here? This is interesting. Do you see these red dots right here? That's how scientists can get an idea of the size of something down there, because sometimes it's really hard to tell. But they know how far apart those dots are, so they can tell how big things are. What is that? All right, so some observations that Sarah and I are making are that there are not a lot of colors down here, except for that red fish that we see. But everything else seems to be very gray and white, kind of muted, maybe some browns. And then, of course, outside of our light range, pitch black. Nothing to see there. Now, I want you all to imagine living in a deep, dark room where there's no light at all. Is it beneficial to even have eyes? If there's no light, I can't see anything, I might as well just have my eyes closed all the time. And if my eyes are closed all the time, I might as well not have them. So not having eyes is actually an adaptation that we see in a lot of animals that live in this deep, dark habitat. Alternatively, what if your eyes were really, really big and they were able to let in just the teeny tiny little bit of light that does exist? Another adaptation we see is that deep sea animals have really big eyes in relation to their body. In fact, I like to relate deep sea animals to animals that are often found on land at night, so our nocturnal animals. Think of our nocturnal animals. What adaptations do they have? Usually teeny tiny eyes or really big eyes. Usually big ears to be able to see, right? Our fish don't typically have big ears. But The idea is that they have these unique adaptations that help them survive. Now, what other challenges, when I say help them survive, what do you need to survive, right? Because my definition of survival is going to be very different than that little redfish definition of survival. Boop. So, in general, when we say helps this animal survive, we mean something that's going to help them find food, avoid becoming food, or find a mate. Those are really the three big things that animals are going for in the animal kingdom. Now, one thing that is really important for animals in the deep sea is to find each other. Because again, there's not a whole lot out here. And in order to continue having babies and growing your population, or even maintaining your population, you're going to have to be able to reproduce. And that means you're going to have to be able to find each other. So, how do animals do that? Can you think of any way to find another animal in a deep, dark room? Remember, close your eyes. How might you find each other? Polo! That's right. Sarah yelled Marco, so I yelled Polo. That's a great example. Communication through sound. So some animals might make a sound. Now, they're probably not down there yelling Marco Polo. Can you imagine being on a deep sea exploration dive and hearing Marco Polo, Marco Polo? Animals are amazing. But they might be down there creating other noises. Raise your hand if you've ever gone into the ocean and heard noises. Yeah, a lot. In fact, with the increase in boat traffic and recreational use, there's a lot of arguments out there that the ocean is getting too loud. And that's actually impacting animals who rely on noise for communication. Now, oftentimes when you go into there, you don't realize you're hearing animals, but you might be hearing crashing waves, you might be hearing the creak of a boat. But the ocean's really, really noisy. There's a lot of snaps and crackles and pops going on. And no, it's not full of Rice Krispie cereal. Instead, it's full of animals, trying to communicate. So fish can often create croaking sounds or snapping sounds. Whales sing across long distance, right? Whale song, right? Those are beautiful if you've ever had the chance to hear one. So these animals rely on sound, and that's something that you can do in the deep, deep ocean without having to see your partner. So sound might be another one. If you find food, good chance somebody else is looking for food too, so you might find a mate in that way. Hydrothermal vents are a great area where a lot of animals come together and find food and then find a mate. Another area where animals tend to congregate in the deep sea, one of my all-time favorite habitats, mostly because it's like a self-created habitat. It's called a whale fall. Let's go ahead and check out what a whale fall is. Now, it's a super scientific concept, okay? Remember those singing whales we talked about earlier? Everybody, do you hear them? Oh, there it was. So singing whales, well, when a whale dies, the whale falls. And that is how we come across this whale fall, such as the one found in Monterey Bay National Marine Sanctuary. Now, again, the whale dies, the whale falls to the sea floor. And it creates a habitat where lots of different animals come for food. So before, all of these areas we've been looking at have been pretty sparse on the animal front. But look around this scene here. Look at all the octopus. Look at all the fish. Oh my gosh, this is so cool. This one dead animal created this incredible ecosystem for these animals to survive and thrive on. So it not only provides them food, pretty important part of survival, but it also provides a space to find each other. I mean, they have picked this whale clean. If I didn't tell you that was a whale, you might not even know. Oh, look, there's those two dots again that help us determine size. So take a look here. Let's see. I count 1, 2, 3, 4 octopus just in that frame. 5. 6? 5. Ooh, 6. Right? So just 6 octopus in that frame alone, where before we were looking at a wide span of sea floor and there was nothing. How do we find this? Yeah. So how we found this one in particular, or whale falls, just in general? So whale falls in particular, again, they're very small in the as much as we think of whales as being very, very large. When you're comparing them to the entire sea floor in the ocean, it's pretty tiny. So a lot of this one I believe in particular was actually just luck on a deep sea exploration. Now, what that means is to get to the deep sea, we have to deal with all of the same things I was talking about before: deep, dark, high pressure, and cold. So humans are not typically the ones going down here. However, in that frame a little bit ago, actually, if we can rewind and see if we can show them that view again. Yeah, we're going to jump back for you, see if we can find that. There it was. So this aerial view right here, this is what we call an ROV, a remote operated vehicle. And ROVs help us explore the deep sea by allowing us to overcome those challenges of pressure and cold water and pretty much everything else that deep sea animals have to struggle with. And so it's a robot. We rely on robots. Now raise your hand if you like to play video games. Nice. I'm imagining there's a lot of hands out there. So if you like to play video games, right? Video games are used using small controllers, and it's the same idea. You're remotely controlling something on your screen, right? So everybody practice. You might have a joystick. You might have separate controllers. You might have, you remember, like if it's a steering wheel for different car games. Well, the same way we might control a video game is really how we're controlling these, but the science is much more intense. This is a control room from a research vessel known as the Falcor, and you can see all of these things are just computers, right? There's the screens where they monitor everything. Let's see, can we look at the arm that they use? Yes, the arm controller, perfect. So again, buttons, screens, on and off switch, I like that, right? Ways to control this ROV remotely. There is the arm it's controlling. You can't tell based on scale. We need two of those colored dots to really show you. But this, how big would you say that is, Sarah? Probably like my size. Yeah, probably like 5 or 6 feet. That's my argument as well. So a tiny little remote arm helping control this large structure. Let's go back to that whale fall. So when we're exploring the deep sea, what we're doing is we're kind of traversing over this unknown habitat. We're mapping the seafloor. We're using sonar. We have one robot here, obviously, to get this photo. That means we had another one. So there's usually two, one on top of the other. And light, right? This is a dark habitat, so we have to reintroduce light. Now, every now and then we get lucky and we find something really fascinating like a whale fall. Other ways we can discover things in the deep sea is by taking samples and learning a little bit more about all of these animals. So many of the animals that we're talking about with you today have been discovered through camera, through videos, right? Or through things washing up on the sea. You might have heard a lot in the media lately about some deep sea fish washing up on the California coast. You might have heard a little bit about taking samples and taking cores and collections from these deep sea habitats. That's how we're learning more about these. Now, let's jump back to the adaptations, right? So far we've discovered a little bit about how these animals might communicate with each other to find a mate. They might be using noise. They might be successfully finding food and in the process finding a mate. But there's one more category that we really haven't talked about, and that is communicating. Oh, look at all these things. These are all examples of unique deep sea creatures. Now you'll notice that for the most part, there's not a whole lot of color on the screen. There are some reds and yellows, some blues, but outside of that, it's really a lot of clear and even like translucent coloration. So animals, they don't put the energy that's needed to make pigment into their bodies. Now red is a pigment that you'll see in the deep sea. And that's because, remember we saw that little red fish earlier? As you go deeper and deeper in the water, red light disappears first. And what that means is these animals will instantly begin to blend in with their habitat. Even so much that at 60 feet, you really don't see the color red anymore unless you shine a flashlight and reintroduce that light. So red is a really common color that you'll see down there. Now, blue light, on the other hand, tends to travel very far. So One way that animals can communicate in this deep, dark habitat is using light, in particular using blue light like this. Now, this is something very special. This is called bioluminescence. Okay, and we're going to break that word down. Bio. When you hear bio, what do you typically think of? Biology, right? Now, biology is the study of life. So, biology, study of life. Bioluminescence must involve life. But what about luminescence? When you think of something that's luminescent, what do you think of? Yeah, it's glowing. So, glowing life, right? Bioluminescence, light created by life. So, bioluminescence is actually a chemical reaction between luciferin and luciferase that creates light in the process of transferring luciferin into oxyluciferin. And what it is, there are a lot of big words, but basically it's a chemical reaction that produces light in the process. And so, animals will use this blue light to communicate with each other, to avoid, to attract prey, to avoid becoming prey, and in all forms of interactions in the deep sea. This is actually a type of jelly. Now, what's really cool about this jelly is we, as scientists, were actually able to create a model of this jelly in the form of a camera. Dr. Edie Witter created this camera called the Medusa and used a light that looks like this, looks like a jelly, and used it to film deep sea creatures. In fact, it was one of the first, it was the first viewing of a giant squid at depth using a light like this, attracting it as prey. Now, anglerfish. Have you ever heard of anglerfish? Yeah, a lot of us have. Remember, they have that little doodad coming off their forehead right here. And at the end of it, there's usually a bioluminescent tip. And what that does is it attracts or lures prey over towards the fish. That's where the angler comes in, angler like fisher. So that's one way of attracting prey. There you go. There's that little doodad. This is a Pacific football fish, I believe. Or is this just a small angler? A different kind? Unsure. But this is an example of an anglerfish. They usually have very football-shaped bodies and then a little bioluminescent angler hanging off the top. Now, this is just again an example of how we attract prey. So either using that Medusa jelly, using our angler. But what about when we're trying to avoid becoming prey? This is actually one of my favorite adaptations in the deep sea. Let's go ahead and check out a shrimp. That's right, a shrimp. This little shrimpy right over here. Now, this shrimp has figured out a way to use bioluminescence to avoid predation, much in the same way that squid and octopus use ink to avoid predation in lighter water. Now, what this shrimp does, it cannot create light. The light is usually created by the chemicals needed for this reaction are usually created by bacteria. And the shrimp has the bacteria in its body. And say a predator comes after it, okay? And the shrimp's kind of bobbing around and avoiding predation and really uncomfortable because it's about to get eaten. What it does is it releases this little packet of bacteria, drops it off, and disappears, okay? Now, the predator all of a sudden is like, I gotta follow my shrimp. But just after the shrimp gets away, that little packet that it dropped off starts to glow. So it's a delayed reaction. So that predator's like, oh, prey! Whoa, prey. And it goes after the glowing bacteria. Let's go ahead and see if we have that. Oh, beautiful. So it's a little bit delayed reaction, and it's basically avoiding predation by distraction. What an amazing way to survive in the deep sea. It's really an amazing way to survive anywhere. Here we go. So shooting out boop, 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 that little packet of bioluminescent bacteria. Again, very similar to how a squid or an octopus might ink up here towards the surface. Now, let's do a quick recap. We have about 5 minutes left, and I want to make sure that we covered the basics. All right, back to the very beginning. Let's talk about what a deep sea habitat looks like. Well, deep sea habitat is going to be dark. It's going to be cold, right? It's going to be a lot of pressure. Remember, so heavy. Everything down there feels like they're carrying the weight of the world because they really are. And there's not going to be a whole lot there. You look around, there's really nothing going on, like anywhere. Okay? Then we discovered that animals, even in this weird habitat, still need to be adapted and find ways to survive. And the way that they need to survive is to find food, to avoid becoming food, and to find a mate to continue to grow the population, or at least sustain the population. So then we discovered how they're able to do that. Many of them communicate with sound. Many of them communicate with light, right? Bioluminescence, using it to attract predators, avoid predation, maybe even using light to communicate with their own kind. We learned that oh gosh, this is cool. Let's watch this. This is another great example of avoiding predation. This is filmed right here in Southern California. Take a look at these waves. We'll wait for a really, really good one to come in. Let's see. Oh, there's a little bit going on out here. Sounds like a big one's coming. Oh my gosh. That is so cool. Now, this obviously isn't deep sea, but it's another example of avoiding danger in the sense that these tiny little dinoflagellates, which are a type of plankton that live in our water, they use bioluminescence in the form of a burglar alarm. And what that means is they're getting tossed and jostled in the waves, right? And they're like, oh my gosh, I'm about to get eaten, or whatever. They don't know what's coming, but they know it's bad. And so these animals will actually light up in a way that attracts another predator to go after whatever is threatening them. The wave's not going to do much harm. Don't know that. So again, this is a great adaptation that we can actually see while sitting on the coast here in Southern California. It doesn't happen all the time, okay? It has to be a nice thick bloom of dinoflagellate plankton, but keep your eyes on the eyes and ears on the news. It'll often be announced that this is happening on your beaches. So a great example of bioluminescence. And again, we also learned that bioluminescence is typically blue due to the fact that blue light will travel very far in the ocean. And so whether it's here in our waves or down in the deep, deep oceans, it's usually blue, maybe a little bit of green. Now, we also learned that animals will camouflage using very gray muted coloration that blends in with their habitat, and also using red coloration that disappears very quickly in water. Okay, so different ways that animals are able to hide. We also discovered what a whale fall is. Again, one of my all-time favorite habitats, a space where this one lone animal, a whale, can fall and create an entire ecosystem down on the deep sea where nothing was before. All these animals come to the smell and they congregate around this animal, and it provides food and nutrients and a way to find a mate. Years. Yeah, thank you, Sarah, for bringing that up. That whale fall can last a very long time. All right, my friends. Now, last, we talked a little bit more about the bioluminescence. We learned about how this process works. Again, it is a chemical process, usually created by bacteria that many animals will host in their body, and it is a chemical reaction that produces light. Okay? Now, I want to wrap it up by asking if you have any last questions to send them in to 562-286-1838. We'd love to learn a little bit more and discover more with you, but we're going to end on that whale fall for another minute or two to really give you all an idea of just how special that is. Now, Sarah's going to bring that video up one last time. Again, if you see anything that you want to know a little bit more about, please chime in. And then we're going to wrap up our morning here with the online academy. What's that? Ooh, they returned to the whale fall a year later. That seems really perfect for us to return to the whale fall at the end of our program. Let's see if we can observe any changes. Wow, so this was 2019. This was 2020. What do you notice? That is incredible. What is all this stuff? Can you tell? All this stuff like around it. Now you'll notice that the skeleton itself has obviously been eaten and broken down, but I wonder what's around it. What's going on? That's a cusk eel, right? Oh. We're not sure. Ooh, we got lots of little crabs. Look, here's an arm of the... Are they... See all these things? Is that the baleen? Yeah. Wow. Well, look, it's collecting a sample. There you go. That is just incredible. So my friends, I do believe that this video is actually available on YouTube as well. I encourage you to explore the deep sea habitat a lot more. There are some incredible things. Even in the last year alone, a lot of different research institutions have found some pretty unique animals out in the habitat, deep ocean and oceanic habitat. So don't stop here. Continue discovering and continue learning about this this habitat, this deep sea where you and I are probably never going to go unless we start to learn a little bit more and get more and more excited and interested. We can always find ways to explore our oceans, and it doesn't stop here. So thank you so much for joining us today. I hope you had fun. I hope you were able to learn stuff. Again, I do apologize for the fact that this was not our normal Spanish Wednesday morning program, but we do hope to be back with Spanish programming next week. Teachers, if you're watching, we do ask that you text in any student numbers that you have. It helps us keep track of how many people are out there watching our programming. Otherwise, thank you all so much. Have a wonderful rest of your Wednesday, and we'll see you next time for the Aquarium of the Pacific's Online Academy. Bye-bye.